Awesome. Fantastic stuff. So, welcome everybody to AI and Deep Learning for Enterprise 11, the meetup about real-world applications of AI. We have some really exciting talks for you this evening, so thank you all for coming out, and thank you to Cisco for hosting us this evening.
Yeah, big thank you. So big thank you to Cisco. Just some venue information. The toilets are just across the lobby by the elevator where you came up. However, there's a security button on the door, so just give either a vessel or someone in a Cisco hoodie a shout before you go out, so you don't get locked out and we don't find you for a while. The fire exit as well. We aren't expecting a drill, so should the fire alarms go off, just exit through the back doors, go left, and follow the signs for the fire exit. And obviously you found the food and drinks at the back, but if you need anything else, just give either myself or Hugh, who are your hosts today, a shout, and we'll be more than willing to help you. Okay.
Cool. So yeah, just quick introductions then. My name's Hugh. I'm a cloud engineer from Featurespace and an AI enthusiast, and one of the organisers of the ADL meetup. We just thought we'd do quick intros because we realised we've been kind of floating around as sort of nameless people for a while now. Thought we'd say hello before we get started this evening. And know me.
Yeah, I work for Demon. We are the main sponsor of the AI and Deep Learning for Enterprise meetup. We're a technical consultancy. I will go a bit more into detail about who we are in a minute, but I am myself a career changer and now a junior software developer as an analyst consultant at Demon.
Awesome. So we have two talks this evening. Unfortunately, Jackson couldn't make it because he's ill, but he will be joining us at an event in the future. So if you're interested in OpenAI embeddings, please do come back for that one. This evening we have Ben Preston from Capgemini. He's talking about some very interesting stuff with bees and AI, which I'm very excited to hear about. And Camacho from Cisco, who's talking about using ChatGPT to do router configuration, which is particularly exciting given I used to work in data centers, so anything that can automate that process, I'm keen. Do you want me to talk about this one?
As we're growing our meetup, we have wanted to introduce a code of conduct. While our meetup is very safe and we have not had any problems so far, we just want to make you aware that we now have a code of conduct just to continue keeping the same format and the same sense of safety and welcoming community that we have managed to build up. So you can see the full code of conduct by scanning the QR code. Otherwise, you can just visit our meetup.com website and find out more about it on there. Okay.
And on that note, just briefly, if you do have any issues with anyone at the meetup, please do reach out to any of the organisers or raise a report anonymously through the link that's on the code of conduct documentation, which you can find through that QR code or through our meetup page. Yeah, thank you.
So I will go through who Demon are now. So we are a technical consultancy who are people first. We are, because we've done this, we have won several awards very recently. We have, we won some last year, but we've built on it this year, and now we have come up in the top 25 technologies best companies to work for of 2023. Alongside the other awards, we've also gained outstanding accreditation for best place to work for as well. And our culture drives this a lot. We have a very open, honest and approachable culture, and it really is a great place to work for, hence why I'm sort of stood here talking to you about Demon today. And so a little bit about AI at Demon. As mentioned, we're a consultancy, so we have different practices. We cover cloud, engineering, but AI is a big part of that, and we are growing and expanding this a lot. Some of the clients that we have had, you can see here, but particularly AI ones are the likes of Conjecture and Domestic in general. And we're really passionate about collaboration, and we think that's key, and knowledge sharing especially. We like to leave, ultimate aim is to leave the world a better place than we found it. So leaving knowledge behind with our clients, as well as sharing knowledge, hence why we are a big part of the AI and Deep Learning meetup. So just to let you know that we are hiring, so we have a lot of roles. Actually surprised myself when I looked at this earlier, in data, cloud, software, engineering, and also DevOps. So if you're interested, then you can either scan the QR code or visit our website, which is pae.mn/openings. Or can find me at the end if this is too quick for you. So the first presentation that we have today is Ben from Capgemini on the bees code.
Cool. Thank you very much. Great. Okay. Thanks, everyone. Nice to meet you. I'm Ben Preston. Thank you, everyone, for inviting me to talk today. On my talking title, Beyond Buzzwords, How Beans Can Change Human Behaviour. So I hope you're in the right place, but just so you all know what to expect, I thought it would be helpful if I gave a quick breakdown of my talk. Probably talk for around half an hour. It's going to consist of just a few minutes of background on myself, the company, team I work for, just so kind of have an idea of how this project came about. I'll then break down the challenge of biodiversity, loss, and our interest and anger in tackling it. I'll explain what the bee waggle dance is. Probably more data-focused element of the talk, perhaps maybe more theoretical. I'll then go into the detail of exactly what it was we built, which was a rewilding tool. And then I'll spend a few minutes at the end kind of talking about what's next and wrapping up, and I think we've got time for questions and everything like that. So as a bit of background, firstly on me, my name's Ben. Like I said, I did my undergraduate in mathematics. Then I worked in the not-for-profit sector, mainly in business development, which was primarily sort of solution-focused work, kind of very much like consulting. Ended up co-running a not-for-profit called BiteWorks, where we had a huge amount of data problems, and technical issues, and booking problems. So ended up building a CRM, which failed. I started coding, sort of retrained as a developer a few years ago, moved to Spain, and then came back to London about 3 years ago to join Capgemini. And who are Capgemini? I imagine some of you, if not all of you, know who we are, but we are a very large consultancy. We have a wide range of streams, including strategy, design, infrastructure, and lots more. I work in a subsection called the AIE, where we solve business problems with applied innovation. Examples include kind of design workshops, where we help uncover the real issue or solution behind a problem. And then kind of developing ideas, such as we did for Burberry for an innovation day, where we kind of created some different products around like testing for fakes and sourcing of materials, and then actually kind of running concepts. So we run a shop in Shoreditch, which was kind of designed to trial different retail experiences so our clients could see if they work before adopting themselves, omni-channel shopping and Google Glass technology for augmented reality and things like that. So that's kind of what we do. So the AIE also sort of sits as a core service. So we often kind of run special projects, for want of a better word. One of these was to deliver a internally funded program called Speech First. This came about from a Capgemini consultant's father, struggled to get right level of speech and language support. And so we kind of came up with the idea of Speech First, which was it's a platform whereby it takes kind of machine learning and AI to take speech and then be able to like process like how effective that was, how well it was doing against. So when you went to see the consultants, you were then able to kind of evaluate rather than just rely on that one appointment. You were able to take a whole body of work. So sort of give a bit of this background really, because this is kind of like how this project came about. So we bid for this funding from something called Tech Positive Futures, and what we really wanted to look for is this project we thought was a huge success. The Speech First, it worked, it did everything we wanted. We trialed it on a group, but unfortunately we didn't have a partner in place to take it on, which was a huge error, and it just sort of sat dormant. It is now working and it is now running, but we realized after that the importance of having a partner take on the program. So we decided if we went for this ourselves and bid for this funding, we would make sure that we had a partner on board. We very much wanted to work in the sustainability space, look at a particular issue. And luckily we met the lovely people of Polyglot, who are a not-for-profit based down in Plymouth. They do quite a lot of things related to bees and plants. They have hives on office roofs. They do seeds. They have an Asian hornet detection system. And we decided to work together to see if we could accelerate and add to any of their projects. Okay, that's hopefully enough background. So on to the problem and approach that we were trying to solve. I'm sure we're all aware we're living through very significant changes in climate and biodiversity. As David Attenborough said, no one wants it to happen, but none of us can afford for it to happen. The solution to this is obviously hugely complex. I'm not going to try and pick it all together apart now. But whilst we were particularly interested in insects, because whilst some plants can self-pollinate, insects obviously responsible for pollination of about 84% of plants that we use for food and about 80% of wildflowers. And their numbers have declined by about 70% and continue to do so by about, well, particularly bee populations, by about 3% each year. Now, if we lost bees completely, the cost to the UK economy would be about £2 billion a year. And while that sounds completely mad, there are actually places in the world, this is China, where it's impossible to get pollinators anymore and the work is being done by humans. So we were kind of really interested in this as a problem. And while obviously large land transformation projects are important, we felt there's like a really interesting role for what individuals play. So we were really drawn to the idea of exploring how we could connect the needs of bees to the efforts of humans replanting, to see if we could somehow create a shared community or piece of work between insects and people to achieve this. And this is where the bee waggle dance comes in. Obviously, it's not exactly a dance, more of a communication pattern, just for anybody that doesn't know what it is, which I imagine lots of you, but it's basically it's a figure of 8 that the bees do when they return to the hive. Incidentally, only about 10% of bees are honeybees. The rest are not. The rest are solitary animals. But they come back to the hive. There's kind of a few things that we're looking for. So there's the length, the angle, and the sound that the bees make. And these tell us the direction, the distance, and the profitability of the pollen source. So kind of like how good the food source will be. Now, the actual waggle dance itself has long been decoded. It was done so in the 1970s by an Austrian scientist called Carl von Frisch, who won the Nobel Peace Prize for it. And there's also been work done to decode a machine learning model. So that's kind of done as well. But what hasn't been done is it's all done in a kind of glass closed space. So it's not in a natural setting. The beehive is natural, but it has to be in a lab environment. And we were really interested in this idea of how this could fit, and you could have labs, just effectively hives, all around the country that then fed back data to you that you could process and be able to understand the needs of an area simply by the bee colony. Obviously, we thought that has multitude of uses, and we were really interested in exploring that. And kind of, ultimately, this is like part of the solution, we think. So this is actually developed by Polyglot. This is their beehive, but with space for a camera, which they also then hook up to a Raspberry Pi. And they'd set this up, but kind of hadn't really worked out in any way what would come next. It was more of it's very much conceptual. They use it as a beehive, but aren't getting much actual data out of it. So we were very interested in this. And like I say, what we were sort of envisaging was that we would have kind of hives everywhere that would then feed back of data. And as this was never put in scope for this part of the project, but as this project grew, you could feed in moth data, beetle data, butterfly data. Kind of Google Earth Engine does similar things to this, but you could kind of build this rich tapestry of what's in your local area. So to try and achieve this, we only had a few months, so we were sort of never going to get to the end. But we decided to break down the work into 2 streams that I'll talk you through briefly now. So one was this kind of feasibility of could this waggle element actually be done, and the second was to build a rewilding tool that could be used for pollinators. As I kind of tried to say in my introduction, the AE were very much focused on actually delivering a tool. It's not simply about a piece of paper. So we wanted to make sure that we had a feasibility, but we left pollinators with something that we can use. And what we wanted to work out the steps needed, look for the problems, and try and undercover some of them. We wanted to integrate them with partnerships, and also to kind of spread what they're trying to do to engage other interested parties, which hoping potentially this talk could do if anyone is interested in getting this project at a later date. And then from the rewilding tool, we wanted to enable people to get localized seed information, because where we were seeing this fit together was that ultimately people would respond to the needs of insects, which sounds ridiculous, but if you think you were getting that messages daily or through something you were interested in, you can see how it become useful. So as a minimum, we wanted localized seed knowledge that encouraged behavior change. And we wanted to build incentives for bespoke planting the right plants in the right place. So how we decided to do this was separate the task into two main areas. The first was called, first was called a Waggle event, and then lastly decoding it. The first issue we had was potentially a miscommunication with the data analyst that we work with. I should have added, I'm a software engineer myself, not a data analyst. I was running the software stream of this, and potentially we had a miscommunication. So I guess it's a real world learning of what they were expecting in terms of labeled data. So they were expecting to see labeled data, which we didn't have. And secondly, there was the quality of the data. So this was actually later in the project when we got it good. But before that, this was made blurry and sort of very, you can see all the light bubbles, and it becomes very, we did manage to do something at a later date. It becomes very hard to kind of properly analyze this, this footage. So we shifted our focus from unsupervised learning to draw inspiration from a paper entitled Automatic Analysis of Bees Waggle Dance, which identified 45,000 waggle events, which formed 511 waggle runs. And we took an approach of breaking down every single frame with high vibration or potential waggles. So we used an OpenCV Python package to remove the background of each frame. And then by calculating the pixel-wise differences between frames, we pinpointed areas with the most significant frames indicating high vibrations. To refine this, we turned to OpenCV contour analysis, which helps spot the most prominent contours in each frame, saving them as potential waggle events. This did produce some false positive, as it registered large pixel differences, even when the bees weren't actually waggling. To address this issue, we applied spatiotemporal clustering. In simpler terms, we started looking for connections between the location and timing of potential waggle events. If multiple potential waggle events occurred in similar locations at roughly the same time, then we concurred that we grouped them into a cluster and concurred that they must have been performed by the same bee. Any waggle events with no nearby events were treated as outliers from the set and ignored. We achieved this clustering using a built-in SBSN CAN model. And to go a step further, we decided to decode these predicted waggles by generating the direction of the communicated pollinating flower. We assumed that the waggle runs were performed along an axis and fit a linear function to every cluster. The slope of this function gave us an estimate as to where the flower was in respect to the hive. This performed really well on lab-generated data, but was fairly unsuccessful on our kind of noisier hive data. We were keen to explore options for a clearer video feed, so we decided to use data from the University of California at San Diego, which, as you can see, is a lot clearer. To do this, we used an action recognition model for bee waggles. So action recognition is all about identifying and classifying actions or activities in the video without pinpointing exactly when they occur. Basically looks at the what without getting into the when. So to do this, we extracted features to describe how actions unfold over time and predict what kind of action it is. To make this network work, we used a pre-trained model, an open source video modeling tool. It was initially trained on 400 human activities, and then we fine-tuned it using our freshly labeled bee waggling dataset, which included 700 video clips. This fine-tune process was a kind of transfer learning, and it meant that we could take the learnings we had from one task and apply it to another. And as you can see, we're sort of ending up with notifying when things aren't waggle events, but we've got movement and confidence interval, as you can see in this, but as to how confident we are that that waggle event happened. Our final approach was to take an action detection model. Now, this was all about pinpointing exactly when and where the actions happened, and looking frame by frame, not only told us when the actions is, but precisely the start and end. So the data set was great, but it only gave us the starting and end points for the frames. So to train our action detection model effectively, we needed more detailed info about when and where the waggles took place. So what we did to level up our data set was first we took a bounding box around the bee, doing the waggle at the beginning of the frame. Then we used a tool called CRST Tracker from the Open CV Python library, which followed the bees frame by frame and kept updating and saving the bounding boxes until every frame was there at the end. And then obviously you can see how this is working following the bee. So in sort of summary of the waggle, we would set out to explore how both unsupervised and supervised machine learning models could help us spot those bee waggles. Our results suggested that machine learning is a viable tool, but perhaps the unsurprising takeaway was that it all boils down to data quality. And if you want to make progress in this field, which we do, and we hope to, you need to put the energy into getting that high quality footage up front and ideally labeling it. That sounds a lot easier than you would think it would be. It's actually pretty hard. We put forward some solutions which we've tested. We've got the light a lot better, but it is very difficult to maintain that camera quality for all the time, basically, with hundreds of bees flying around. So as I said, we're sort of happy with where this got to, but obviously going forward, we feel that there's a lot of work here that another team could take on to make even more of a success. So as I said at the start of our goal with the waggle was very much focused on proof of concept. The rewilding tool, we really wanted to make sure produced something that could be used by the client, if you like, used by Polynize. And we really wanted to focus on that. So first thing we built was a C prescriber. So it's a tool whereby you can, how we built it first was we took that idea of what we wanted. It's just an API at the end of the day, but what we're envisaging is that you could take in API calls at a later date from the bee data, from beetle data, from butterfly data. And then what we did is we looked up a call with iNaturalist and another couple of plant sites so that we could identify what was in an area. And we used those tools particularly because the partner that we work with, and lots of partners, they do things with bioblitzes. This is one way of identifying how an area is progressing. So there's a few groups that you sponsor a meter square area, and then you track the biodiversity in that. You upload data like that to an iNaturalist, and then over time you can see the changes in patterns. So I can show you how this works. So yeah, obviously you put in your postcode, goes and looks at the database, and then it comes back with firstly a seed packet recommendation that was the sort of standard one, but then boosters that fit your area with a link to go and buy them. That was kind of step one, if you like. The second element of this was then tracking where this what we did with this data, where it went, and we're sort of envisaging this data growing and growing and growing over time. So when the seed packet comes to the person, on the back there is a QR code you can scan, which then starts a logging process. So Polynize is very clear on being able to log this data to then feed back into the API to build this community. This was the kind of way of making this work. So basically, as you scan the tool, you end up at a site, which ultimately leads to a logging location. You can plant where your seeds have planted, get the information that Polynize wanted for various reasons on where it was planted, who gave them the seeds, and then go on and build forward. So they were very interested in this idea of rewards, firstly through badges, but they wanted to kind of expand this out. They do a lot of work with schools, so they kind of ultimately want to take this to be prizes and parts of a curriculum. And then from there, again, feeds back into the API. That data is stored on our database, and then they can look and provide different recommendations. And obviously, if you buy this recommendation and then you plant it the second time, it won't tell you to do that. Or if your neighbor buys it, it won't tell you to do that because it's geographically based. So what this looks like simply as a data upload journey. So one thing, I mean, this is very sort of basic model we built for them just because we wanted it to be able to scale. So it's just with Firebase, but we just where they'd had before was very much they took a data collection that came in one chunk or it didn't come at all. And essentially we built something whereby step by step they could add to it. They could take the QR scanning to take the data in, and through that method we were kind of able to accelerate things a bit. The final thing that not quite final thing that we built them was a QR code scanner. So we wanted them to be able to measure these and distribute QR code scans. So we just built them a very basic tool whereby you could scan a seed packet, define where that had gone, so it would then be processed properly. And they use this kind of like I say, they do a lot of work with schools. One of the elements, this was for their ordering for take on through their shop. But where they wanted to get to with bulk upload was that if they're giving to school and there's thousands of seed packets going out, this way they can monitor and define them easily. Beyond that, we help support them with building a bit of a front end site. So we took some of the data that we had to build a few small web APIs, basically. Kind of data studio that we did with Looker, just because we found it was easier for them to manipulate over time to use for different clients. And then also a kind of map that was over time showing how and where things were progressing. We built them a data dashboard again, so we can kind of track how this is going. So this was what they'd had for the 5 years previously. And this was after a month of implementing this. We've been able to dramatically increase the level of seeds that they had. And obviously we're hoping that they can use this again because we built it in Looker. It's much easier to change for a non-technical person, and they can go through and adapt their data. I guess the sort of final thing we did with this was we wanted to kind of play with this idea of the QR code. So what we'd actually envisaged is kind of building something out of dead bees, which we were not allowed to do. Bit of a shame. But we wanted to build a QR code purely based out of that you could scan. But again, we wanted to leave them with an asset that they could use. We put this up on a billboard in London, so you could scan the flowers, scan the bees, get taken to a slightly different version of the site that we made them that explained the concept, explained what they were trying to do. Yeah. So yeah, what's next? So more data capture for sure. So we launched this at the very end of summer. It's completely the wrong time to have a seed planting tool. I mean, we're still quite pleased with the results, but we're really helping them build to use this for. I mean, we think that the main audience for this is schools, really. So being able to use that kind of competitive element against each other. We've put them in touch with some other academics that are doing similar things. So kind of very keen to see the actual development of the Waggle go forward. There are other organisations that are kind of doing it as well, so that we put one in America, one in France. Yeah, that's it really. If you want to get in touch at all or find anything more about it, you can contact me on my LinkedIn, or we have a blog as well, which has some of this data up there. So I hope that was some help and interest to you all. And yeah, if you've got any questions, happy to take any.
Awesome, thank you, Dan. We have time for a few questions. Is there any questions for Ben about that presentation? Any takers? Over there. A very lively bunch this evening. Okay. I guess I I had a question that I was thinking about asking, but now on the spot, it's completely gone from my head. In terms of actually running the computer vision models that you were using to analyze the rival dances, were you just running that locally on your machines, or did you end up building out a solution for Polymize to sort of do this in a more production way?
We just ran it all locally on our machines because, again, because we had some data analysts that came and did that work. Because they'd mind me saying, they're not super technically minded in a computer sense. Anyway, they're very good with the camera stuff. Yeah, we sort of thought we tried to manage everything in terms of running this project. It would be as easy to maintain, and this was the main learning that we took from the speech first was you can build very complicated models that work very, very well, but ultimately one of the things we found with the speech first project is because all the servers it was all running on AWS, everything would go cold, and then when people would come and try it, the boot up time would be so long that they'd think everything was broken. So that was kind of a reason that we've learned from and taken forward is that you have to have that ability to run it once you've gone.
Any questions from the room?
I just wanted to know, what was the name of the model that you used for recognizing the movement of the bees? I mean, was it something like YOLO, or was it detecting the movement in real time?
I'm not 100% sure. I sort of wrote all the names down so I didn't forget them. Oh, you mean the action detection model?
Yes.
I'm not sure. I have to look to my notes and get back to it.
Any other questions from the room?
I have a question. It's not a technical question. How much was the budget for the project?
I think it was like 70,000 euros. So
quite a lot of work for that project.
Yeah,
for the budget. So.
Yeah, we really tried to stretch it, to be honest. It was a lot. That's partly why we tried to make it as quick and efficient as possible, and we used a lot of fairly basic web apps. I would say I wouldn't say the styling was over the top, but I still think it's good. We tried to think about their site, but yeah, that was tried to keep it pretty tight. We all operate on cost as well.
Any other questions from the room? I see one over there. Okay. Thank you, Ben.
Cool. Thank you.
Everybody, so hope you had a nice break. So I'm going to introduce Tom now, who's our host for the evening and who we have to thank you for tonight. And he's going to introduce the company Cisco and who they are and what they're about.
Yeah, sounds good. Hello everyone, and welcome to the first Cisco AI and Deep Learning meetup. Hopefully you've all had enough snacks and food and everything. Yeah, my name's Tom and I'm a software engineer at Cisco. I work in the Cisco Device Technology Group. So basically work on all these things that you can see here, cameras in various forms. Yeah, been part of Cisco for 5 years, part of various teams. And yeah, obviously currently in the devices team. So just a quick intro to my colleague today, Carolina Camacho. She's going to be doing the talk today. And yeah, I think there's a slight mix-up with the picture before, but that's okay. But yeah, this is Carolina here. She's actually on the call at the moment, so she'll be able to say hi later. So I just thought I'd give a quick introduction to what Cisco do in the field of AI, and just give a very quick introduction to that, and also what the devices group actually does as well. So yeah, in the devices team, as I was saying before, yeah, we make these devices here, which you can see. So mostly, my team mostly focuses on the touch devices. So these include the big WebEx boards that we sell, to the desk and the desk and the desk mini. Second, I lost my thing. There we go. Anyway, so all these devices include a selection of high quality cameras and audio arrays. And use a custom operating system called RoomOS. So I'm part of one team that develops the whiteboarding application within RoomOS, and that's all to do with collaborative whiteboarding, across the wire within a call. We do also support, as well as WebEx, many meeting platforms. So we do obviously support Microsoft Teams, and have actually been certified as well to support Microsoft Team Rooms as well as RoomOS. So the only vendor that really supports the cross third-party vendor provider of meetings. Yeah, so to the next slide. Sorry, I've got about 1 billion windows open with the meeting. So yeah, Cisco have a huge involvement in AI. I can't list everything on this slide, just fill it up with too much. So I thought I'd just focus on the stuff that we are involved with in collaboration. So that's the collaboration department that includes WebEx, the devices, and everything like that. So there's two kind of things that I'll sort of go through anyway. There's the stuff on the devices, and there's the stuff on the WebEx clients and the various clients that we provide anyway. So the devices themselves, as I was saying, have incredibly clever microarrays to be able to detect where people are in the room when they are speaking, be able to detect to be able to cancel certain noises from the meeting as well. So do background noise removal, and also allow you to optimize for things such as music as well, for music mode, so extra high quality music input too. And yeah, the cameras themselves have various models to be able to do the background removal and various other things related to face reframing. We have a ton of new features coming out, which I'll show you in a second, related to cinematic meetings. So this is using very clever camera techniques to have a seamless experience when people are in a meeting. The WebEx clients do a ton of things. We have our own AI assistant that's sort of built in-house, which is available on devices too, and also on the client. So this does things such as live translation and transcription, meeting summaries, chat summaries, and a catch me up feature as well. So if you're, say, for example, partway through a meeting and you've missed the first 5 minutes, you can quickly go back and it will provide a summary for you. So we do actually have a page going through some of these features that have some fancy. I've lost my mouse. There we go. I'll find it. There we go. Cool. So yeah, this is the meeting summaries feature. Let me just zoom in a little bit. Sort of goes through and gives summaries of what's happened so far. There is actually AI models currently running on obviously this device in this meeting. So we'll hopefully have a nice little meeting summary showing all the various sort of things that were discussed in this meeting. And I'll be able to share that hopefully at some point. We also have various things around message tone as well. So if you're writing a message and you want to change the tone for whatever reason, if you're speaking to a specific person, you can change it to be more professional or a different style automatically. Some be right back features, video summaries, real-time translation, background noise removal. These are all things in WebEx Suite. And devices, like I was saying, we have clever ML models to be able to detect the people in the room and to intelligently switch between cameras depending on who's speaking and who's the focus at that time. So there's a ton of these things. You can look at them afterwards anyway. There's a QR code in the slides, so I just click to it. If you want to check it out, you can do. And just quickly, what am I doing? There we go. Sorry. There we go. And yeah, just working at Cisco anyway, I just thought I'd do a brief slide on that. So yeah, we're the #1 best place to work in the UK for a super large company. We have a huge engineering presence in the UK and across the world. So obviously working at Cisco is a great opportunity to work across various nationalities and nations. These are just some of the highlights of engineering teams that I know of based in the UK, but there are tons that I just obviously don't deal with on a daily basis. So obviously just wanted to highlight that, and that's it. this is just a very quick summary. Obviously, there's a lot more detail on the website and on the various videos that have been presented in WebEx1. So there was a conference last week that went through a lot of this in a lot more detail anyway, so you can find some information out there. Before I go on to the next talk from Carolina, is there any questions at all related to some of the stuff that Cisco do or anything that
Hi. This is just Cisco in general. What would you say the highlight of working for Cisco has been for you? I know you've highlighted like some of the tech stack, but for, like as a senior developer yourself, what have you found working for Cisco is like?
Yeah, I think that the two that's a really good question. The two big things for myself are the diversity of the team. I work with people, my team is across the UK, Ireland and Norway, and also China, and also the US. So I'm continually dealing with people across the world, which is a real massive positive because it gives a lot more perspective on things, I think. So that's one big sort of positive for me. And the second thing is the versatility of work that I've been able to do. So I've been part of 5 different sort of teams since working at Cisco. And I've been able to sort of switch between teams as I wanted to, and for various reasons. And yeah, that's been good for myself anyway when it comes to my career to really get an understanding of hopefully a lot of different areas, or at least pretend to know a lot of different areas anyway. So yeah, so that's it. Any other questions at all? Cool. So we'll hopefully take it over to Carolina. Are you ready to go next?
I guess you can see my screen now, right?
I'm just going to change the, I'll just quickly change the layout stuff quickly. 1 second.
Sure.
There we go. Great. Fantastic.
Okay.
Brilliant. There you go. Go ahead.
Hello, good evening. Nice to meet you. My name is Carolina Camacho. I'm a network engineer. I work for Cisco. I have an experience of 13 years already in the networking field because it's been 13 years since I've been working for Cisco. And maybe you're wondering, why do we have a network engineer here speaking about ChatGPT and deep learning and all those type of things? Well, let's say that I'm a curious person. I always try to be up to date with technologies and with new tools, and I try to introduce them in my day-to-day work. So I can make it more easy, and I can make my day-to-day work easier, and I also can automate things. Okay. So let me see if okay. So our goal here would be to take advantage of ChatGPT knowledge of YAML to build a topology for Cisco routers and to configure its interface. I'm sure that you are aware that ChatGPT is really good with programming languages. For example, Java, Python, it's really good. Also, it's really good for data serialization languages like YAML. If you don't know, YAML is a human-readable data serialization language that is very often used for writing configuration files. We happen to have some routers at Cisco, virtual routers, where you can build topologies using this serialization language. So that is why I used the ChatGPT knowledge about these data serialization languages to make my life easier. And I'm going to show you how, okay? This would be the agenda. I'm going to explain you what an XRD is, that it's just a virtual router. I don't pretend you to be like experts in this type of routers, but just to go to the bottom line here, that is just to know the capabilities of the LLMs. LLMs, like for example, in this case, it's ChatGPT. Know their capabilities and know what they can do for us, okay? So this is just a use case, and it has limitless possibilities. I'm sure that you can come with another many use cases, but this is just an example for this, okay? So this will only take 10 minutes, by the way, so it would be quick, but I'm sure that you will get the bottom line of this. So XRD, what's XRD?
I spoiled a little bit earlier that XRD, it's a virtual router. It's quite new. It was released on July 2022. It has different use cases. It can be used as a lab simulator, also as a virtual route reflector. And the funny thing here, as you may have noticed, it's that it's quite new. So ChatGPT doesn't even know what XRD are, you know, because as you may be aware, ChatGPT knows until 2021, and this is much younger, in 2022. So ChatGPT doesn't even know what XRD is or what XRD looks like. The funny thing here, as I said before, is that to create a topology in XRD, we use YAML files, and ChatGPT do know about YAML files. So that's the key of the question here. So how do we create a topology with XRD? How does it look like? As I said, it's a YAML file. It has 3 sections. As you can see here on the left, this is an example. It's a really easy topology. We just have 3 routers. As you can see, the first section, we have every router in the topology. We have the image that is running, the boot script, and we also have a list of interfaces that the container will have. I'm saying container here because as we will see later, each router, each XRD router, it's a Docker container, okay? So I'm saying a container, but in fact, it's just a router. So there is another section where we draw the links between X container, X router. So this will be the wires that are connecting every interface. So as I said, here we have 3 routers and we have the connection between each router. And then we have another section that is not that important right now, but it's some bit of configuration that we need in case we need to have the host accessible from the outside. Okay, so knowing this, we're going for the next step. As you maybe already noticed, this YAML file is really short. It's just 3 writers. Normally, the topologies are much bigger. For example, I have created topologies of around, with XRD, with these virtual routers, of around 20 routers, for example. You can imagine we have tons of wires between all those routers. So sometimes it can be really tedious to write those big topologies by hand using YAML. Even though YAML is human readable, it's the indentation in a YAML file is very precise, you know. You cannot miss a space because if not, it won't be understandable. It won't be readable. So I figured out, why don't ask ChatGPT for help? Let's see. As I said, ChatGPT does not know about how to create a topology in XRD, but one of the tricks that we can do, that I'm sure if you have done some prompting on ChatGPT, one of the usual things that we do when we write a prompt for ChatGPT is to include examples. That's really handy to include examples, so the LLM knows what you're expecting as an answer, okay? So what we're going to do is just to give an example of a topology in XRD, and then we're going to tell the LLM, what do we want? Okay, this is a topology of 3 routers, but I want you to write me a topology of 5 routers. In fact, this is the topology, the one that we have on the left. This is what we want to get. It will be a topology of 5 routers. They are connected between each other, as you can see here. So let's press play and let's see what do we get. So we introduce the example. We say, how do we got the connection between the routers? And ChatGPT will start to give us all the configuration file. As you can see, it knows how a YAML is written, the format. So we also get this little square where we have copy code and we just need to copy and paste later. As you can see, we have router 1, router 2. If we check in my picture, router 2 have 3 interfaces, and that is right. ChatGPT got us 3 interfaces. Router 3 have 2 interfaces, and we got 2 interfaces, that's right. Router 4 should have 2 interfaces, and we got the 2 interfaces. And router 5 should have 3 interfaces. Also remember that the link between the routers is really important as well. And ChatGPT has to get not only the numbering of the interfaces correct, but also the links, no? So for example, here we have that router 1, interface 0 will go to router 2, interface 0. Router 1, interface 1 will go to router 3, interface 0, and so on. So we have all the links. And then the bit of information that I told you about before that is needed if we want to access any router from the outside. Okay. So we got our file. Then, as always, we get some information about what we just got. But what we're interested in is the file, okay? So I got the file, and I'm going to draw what did we get from ChatGPT. So this is the network that ChatGPT have for us. The number is correct, because as you can see, we have the 5 routers, we have each of the interfaces. Then we're going to test it in real life, and you will see if it works. But let's do one step more. I don't know if you have ever configured a router or ever play around with routers, but when you start with a topology, you have to not only set up the routers, but you also have to go inside every interface, and the first step that you have to do is to give them my IP address. So you have to go inside one router, go inside one of the interface, type the address, then go to another interface, type the address. This, if you do it manually, it's quite tedious, and also it's prone to errors, you know? So I thought, why don't try to challenge ChatGPT to do that? For this, again, I've written a prompt with an example. Okay, first of all, I'm giving ChatGPT all my links. He knows that every link, the IP address of every link has to be in the same subnet. And I'm going, as you can see in the top of the prompt, you can see an example of how do we write IP addresses at Cisco, okay, in a Cisco router. So let's give some time to think. And now we're getting the configuration. As you can see, ChatGPT is giving even the no shutdown word, you know, that I didn't tell, but it knows a little bit about Cisco routers, and it knows that we need a no shutdown to get the interface up. So we're getting that. And we're also getting the configuration for each router in a different square. So it will be easier for us to just copy one of the squares, go to that router, and just paste the information. Okay. I have found that although ChatGPT knows about Cisco routers, I think as of now, the software part is more, I don't know, it knows better about programming language and things like that. But as you can see, it's also capable of giving us some router configurations. Okay, so let's continue. And this is the network with the IP addresses that ChatGPT gave us. Okay, we have the 5 routers. This is the subnet that we have. And this, what I have written here is just what ChatGPT gave me. And without doing any trick, I just copy and pasted all that information into one server that I have. Here is a server that I have on somewhere at a Cisco, in a Cisco place, okay? Here in the first file, Docker Compose, here I have the YAML file that I got at the beginning. This is the topology. And then I have the 5 routers. These 5 routers have inside these configuration files, have the information that we just got from ChatGPT. So we paste this and we run the topology. As I said before, every router is just a Docker container. So we create the networks, we create the volumes, the Docker containers, and we get we launch the topology and we get everything up. Okay. So now that we have the containers, we can go inside one of the containers. For example, here it's an example of going inside one of the containers. As you can see, it looks like a Cisco router, of course. And we have here the configuration, the interfaces and the IP addresses that we configured before. We have it here configured. So it's working. We got our routers up, they are working. And we also tried to ping the other side of the wire, the other interface. And as you can see here, because this little mark here tells us that it is working. The other side is responding. So the configuration that ChatGPT gave us, it's good and it's working, and well, it can make my life easier. Thank you very much. I hope this has been informative for you, and that you play around with these tools and automate as much as you can. Thank you. I don't know if you have any questions. I'm going to stop sharing because if not, I cannot see you. Now I see you. If you have any questions, just go ahead.
Yeah, we have one question.
Sorry for so far away. I'm kind of wondering what level of automation can you drive with that? I mean, what if you maybe not this quarter or this year, but maybe next year, this time next year, what will be the level? Now you get rid of scripting YAML, which is good for everyone, but maybe what is the ultimate input that you can give, and then just let an engine run that's sort of driven by a large language model, and that gives you the right configuration at the end. Kind of, if you're sort of dreaming ahead, what would be the level of automation you can drive to? And then the once you have that, what kind of sensor input? I mean, looking at this crazy room here with all the microphones and everything else. I mean,
She can see you anyway.
Oh, that's good.
Camera just here.
You know, I'm looking at the microphones. That kind of weird stuff. You know, what is it that you actually need? You know, maybe you can, if you put a piece of kit in a room, maybe you can kind of self-configure it using this approach.
Yeah, well, it's hard to tell how the level of what the level of automation would be in 1 year time, because as you can see, this is evolving really, really, really fast. In fact, the things that we're explaining today, maybe they're outdated tomorrow, you know what I mean? So what I guess is that, yeah, this will evolve. Maybe at some point we can even, we will not need to even give the example in the prompt, but maybe we can have it pre-learned, you know? Also, there are some techniques in the LLMs that, for example, you can have a database, an internal database that is not out there on the internet. And with some vectorization, the LLMs can get that information from your inside database and use it to create a more informative answer. And well, this is already here, and who knows what will be like in 1 year time. I don't know if this answered your question.
That's right. Thank you.
Any other questions from anyone in the room?
Online?
Yeah, if you're online, if you just want to raise your hand, I can unmute you.
One quick question for me, Alana. Thank you for that awesome presentation. How did you find the process of figuring out how to do this, going from doing this manually to using ChatGPT? Were there any kind of roadblocks or any kind of parts that might have been sort of more fiddly than doing it manually that came up?
Yeah, really good question. Yeah. Before using ChatGPT, of course, I have done several topologies, you know, by hand, and I knew already that this was really it's tedious, you know. You spend a lot of time just getting all the indentation rights and everything, you know. So once I started using ChatGPT, I thought, why not? Let's try. And the thing that for me was the most difficult, thing was to write a good prompt, you know? I don't know if you're aware that prompting, it looks easy, but it has a lot of science around it, you know? There are a lot of techniques that you can learn, and they're really interesting. At the beginning, I didn't know any about prompting techniques, and I didn't know anything. I just go like trial and error, and let's see what ChatGPT likes best, you know? But then after a while, I learned some prompting techniques, some things that could help me. And for example, like giving context, or for example, giving the example, what do you need, you know, what are you expecting? So if you give the machine less options and you let them know what do you need, it's easier. For me, that was the worst part, to go from, okay, I need that, I need this, and to how to ask the question so I get the answer that I need. Yeah, that was a learning process, I would say.
Awesome. Fantastic. Any other questions from anyone in the room or online? Okay. Sorry, Missy, no, you go.
It's okay. I just want to know, how do you confirm the output? Is it like you personally confirm it and then you apply it in your work, or are you trying to do that part automatically as well? Because as you know, the output of the LLM models are not the same all the time. So, I mean, it's going to be varying a lot.
Yeah, really good question, because sometimes you get an answer that is not correct, and you have to somehow, you always need a human there to test it. Well, in this case, when we build a topology, we need to also to draw the topology, you know? So what I did, it was just to confirm it. Instead of drawing the topology first, I first asked ChatGPT to give me the YAML file, and then I draw the topology following the YAML file. And this way I could see if it was missing maybe some wire or or maybe the number was not correct. So first I got the YAML file, then I draw the topology, and then I test it in a real environment. Of course, you can skip the drawing part if you want, and you can go directly to test it in the real environment. If it's working, okay, you have it. But if it's not, you will have to troubleshoot it. And to troubleshoot it correctly, I think it's easier and it's more handy to have the drawing.
Brilliant stuff. Any other questions in the room or online? Okay. Thank you, Carolina. That was fantastic. Thank you very much.
Okay, thanks to you. Thank you, everyone.
Okay. So just before we wrap up, we have a couple of quick messages. Just whilst we're getting slides set up, another big thank you to Cisco for hosting us this evening. There are not a lot of people in London who have space to host 40, 50 people in a room and set them up with all this amazing technology. So thank you very much for that. And thank you, Tom, for looking after us this evening, and for your colleagues at the halls who've been taking very good care of us. Couple of quick messages then. In that case, if you or someone you work with are doing stuff with AI or data science and would like to talk at one of our events, please do reach out. We're always looking for more speakers, particularly if you're a first-time speaker, or perhaps you're someone from academia who doesn't normally speak at kind of more enterprise-focused events. Please do reach out. We're always looking to sort of bring people in, support people. As I say, if you're a first-time speaker and you'd like some support, do reach out. We can do coaching and mentoring and that kind of thing. We have a call for papers on this QR code. The link is also available on Meetup. But if you give that a scan and give us your email and a kind of a brief idea of what your talk might be about, we can work with you to find a time in the calendar for you to come speak at one of our events and support you in doing that. And the next slide. Awesome. So our final event of the year is on the 6th of December. The Doom offices over in Paddington. They are, as I'm sure you'll be very well aware at this point, they are the main sponsor of this event, and we're very grateful for everything they do for us. So we'll be over in their offices on the 6th. We've got some really exciting talks lined up, very, very full schedule in December, including some exciting stuff about Hugging Face models and using ChatGPT to build reliable blogging tools, not just tools that will write just anything. So I think that is pretty much a wrap from us. We have this space until 9, so if you're having any conversations with anyone you've met this evening, you'd like to continue them, you're welcome to stay until then. But we do ask that once we reach 9 o'clock, if you could make your way home, or I mean, do whatever you want to do, but please, off to bed, all of you. But do whatever you want to do come 9. But just if everyone could make their way out by that point, so that we can get our Cisco's hair up at their office back to rights, that would be great, because we'd very much like to come back at some point. So that's all from us. Thank you very much for coming.
Thank you.